Many new users of 3ds Max find their first steps with the software to be relatively painless. Its architecture is designed to provide easy access to its powerful functions and procedural workflow, with a relatively low level of technical knowledge being needed. Of course, those who have been through the journey of learning how to use 3ds Max, and more specifically the stack, will appreciate that a firm grounding in the fundamentals of procedural workflow and the nodes that lie behind it will pay back greatly in understanding this system. So what exactly is the stack? The stack is 3ds Max's main interface to the node-based engine that underlies the software. It allows us to build chains of discrete units called modifiers that allow us to take a simple primitive object and evolve it through into a complex final result. The basic premise of the stack is that we start with a simple object such as a cube as a foundation, and then we add a series of targeted tool-like units to our object, each of which changes it in some way. As these tools always modify our object in one way or another, Autodesk settled on the name of modifier for these tools. These modifiers are depicted as being placed one on top of the other, like boxes, with each building on or changing the object in some way. As the display is vertical, the modifiers are seen to stack up, and hence the interface to these modifiers is called a stack. Let's actually have a look at the stack in 3ds Max. If we look in this panel here, which is called the modify panel, you'll see that we have a number of different elements which we'll actually cover later. So let's very quickly actually show the stack in action. This is actually the stack here, this window. And if I get some modifiers and I apply them to this teapot, we'll get a bend modifier. I'll actually just bend the teapot over in this direction. And let's say we get a lattice, and I'll just actually make some of the things in that a little bit smaller. There we go. And I'll add another modifier. Let's say a freeform deformation. We'll actually put this lower down in the stack. I'll actually put it here. And I'll just go in quickly and edit the control points on that. So I'm just using some of the features here of the stack. I'll just scale these outwards. There we go. And now if I go back up the stack, you can see that each of these modifications is applied. Now, it's important to realize at this point that each and every object you see in 3ds Max is the product of its base object, which you can see here as a cylinder, its stack of modifiers, which you can see here, and its transform node, which you can't actually see. What do I mean by this? Well, to make 3ds Max more efficient, all the objects in the scene are treated as having no transform for the purposes of evaluating the modifications carried out in the stack. What this means in plain English is that each object is actually at the center of the world with a position of 0, 0, 0, a rotation of 0, 0, and a scale of 1, 1, 1, before the modifiers are actually applied to it. Now, this cylinder is actually in the same position that I've just described. If you look at its transform, you'll see it's got a x, y, and z position of 0, 0, 0. If we go up to its scale and right-click on it, you'll see that it's got a scale of 100, 100, 100, or as I said earlier, 1, 1, 1. You can think of it whichever way you want, either as a percentage or as a fraction of 1. And if we go to the rotation gizmo, you can also see that we've got a rotation of 0, 0, 0. So the object isn't rotated at all. And that's actually the way all the modifiers treat the object. But what's the reason for this? Well, each object is acted upon by the modifiers in its stack, as you can see here, from the bottom to the top. At each point, the object is altered in some way by the currently evaluated modifier, but its actual transform never changes during this stage. Finally, at the top of the stack, when all the modifications have taken place, the transform node for that object comes into play and its values are applied to the object, transforming it into its final position in the world with its final orientation and scale. Why does Max actually handle things this way though? Well, the main reason is that each modifier actually then knows that the object is not transformed in any way. And from this, it can also assume that all of the sub-objects of that node have no transform applied to them either. As a result of this, each modifier does not actually have to adapt its effect to the position of the objects in world space, which otherwise would be the case. For instance, imagine we have an edit mesh modifier that has changed the position of each vertex of our object. Let's actually do this. I'll go in here and I'll put an edit mesh modifier. And I'll just select some vertices and move these around. Not actually trying to make a nice looking model here, this is just to show, you know, the principle in action. As you can see, the edit mesh modifier has actually allowed us to change the position of most of the vertices in our object. If the object were transformed already in world space, the modifier would have to remove that object's world space transformation. What I mean by world space transformation is actually, you know, if it was positioned here, rotated like this, and let's say scaled. That's what I mean by world space translation. So if we actually had a case, as you can see here, the edit mesh modifier would actually have to remove the object's world space transformation, then perform its modification to each vertex, and then reapply the world space transformation once again to put it back in the same position. If it did not do this, your mesh would actually deform as you moved it around within world space, which would make a pretty useless system all round, really. Of course, always applying these transformations at the top of the stack does not seem to be such a big issue. After all, the mesh of the object has to be transformed into its final position and orientation at some point. However, doing the transform at the top of the stack means it only happens once per stack evaluation. And this has a major impact upon the speed of the software, especially with complex stack arrangements. In this case, we've got a very simple stack arrangement. You can see we start off with a cylinder, and then we modified with an edit mesh. But we could actually add, you know, a number of modifiers on top. We could have a bend, and let's say we could have a twist, let's say, or a taper. Let's put a taper on there. Then we could have another edit mesh. And so on and so on. Now, every optimization in this area can help to improve the interactive speed of a character rig, for instance. And that's imperative for a character animator. So as you can see, this is a pretty major optimization, as it means it only actually ever happens once per stack evaluation. And when I say stack evaluation, I mean what you can see here as I step through: cylinder, edit mesh, bend, taper, edit mesh. So at each point, rather than the transform being removed, the object being taken back to world 0, the rotation and everything being reset, then the edit mesh being applied, then it being transformed back into this position, then that being removed again, the bend being applied, then it being transformed back into this position, and so on. Instead of doing that, I mean, you can see it's blatant. It's very, very wasteful. Instead of doing that, it just does it once. So although you can actually see the object in this position in space, in reality, the stack treats it as if it was actually zeroed out on all the transforms. So in other words, the modifiers are actually seeing it like this. If I go to the world position, it sees it as being here. If I go to the scale, it sees it as being 100, 100, 100. And if I go to rotation, again, it sees it as actually having no rotation applied. Just like this. Now, because this actually is the case, it has to be borne in mind when working in Max, as some operations have to have the world transform applied to them explicitly because of this system. If you're actually working with an object below the point at which the transform is applied, you may actually have to apply that transform yourself manually to make the stack actually work in the correct way. So we can think of our most basic stack like this. We have a base object, say a cylinder, a teapot, a cube, whatever. And this is at world 0, 0, 0, with a rotation of 0, 0, 0, and a scale of 100%, 100%, 100%. We modify it in some way with modifiers like bend, twist, edit mesh, skin, or maybe we actually do nothing at all to the object. It's quite feasible to actually get rid of all of these and just have the basic object, like this. We now have its final mesh shape at the top of the object stack. In this case, the stack's very simple, it's just the base object. We then take this mesh and we transform it into its final position, rotation and scale. and this is actually displayed in the viewport. In this case, you won't actually see any difference because the rotation, translation, and scale, they're all zeroed out anyway, so there's no real difference. So, as you can see, at all times our object is shown in the viewport in the position defined by its transform node. So the procedure of stack evaluation and final transformation takes place transparently at all times whilst working within the GUI. However, behind the scene, the stack is always fully evaluated, one modifier at a time, and finally the mesh transformation is applied before it's displayed in the viewport.